Hey guys, this is where we wait on the equipment to render. So we're just doing that real quick while I get things all set up for our second anniversary broadcast. First one was on the 27th of June of 2015. And excuse me, I did not get the clips up from back then, but I might be able to force them to play through, so you just have to be patient, and I'll try to get that going. Anyway, let's start the introductory roll. Hey, there we go, and you got to see the sea breeze roll in, and showers outside a little bit earlier, about 10 minutes ago. And what we're looking at right now, the scene is looking a little bit like this. Cleared out pretty quickly, so the marine air did make it in, modified of course a little bit. But let's head straight to the charts and take a quick look, and there is a little bit of what you can see of the sea breeze right there moving inland. You can see it's definitely a mesoscale feature. It's not really resolvable on the charts here very well. We see mostly the synoptic scale detail. So we got the southerly gradient coming up from the Gulf, and you can see high pressure out over the northern Mississippi area right here. So yeah, the flow is coming up through from the Gulf, and let's take a look at the moisture. Yeah, there's the moisture field. So moisture axis kind of spread all over, but what's really important this time of year is the theta E ridge. And you can see that right in this area here. So yeah, if you're looking strictly at dew point fields, it kind of looks like a big mess. You've got 60s all over the place and some 70s creeping inland, but really that theta E field. Let's go back to that, and you can see that that's pretty much right over Houston all the way up to Dallas. Let me take a quick look and make sure that our audio is doing okay, because I was kind of in a big rush there at the beginning. Sue M says, happy anniversary, Tim. Cake, where's the ice cream? Yeah, I have not had a chance to get to the store, but that would be a good idea. It's as hot as heck outside. Don't you study the weather? Good evening from boiling South Florida. From Ryan, heat index 105. Wow. And I appreciate the comments there. Greg Kerner, also checking in, dew point 39, temperature 70 where he is. David Holcomb, happy to make it to a live cast. Welcome. And Fun with Tech, happy birthday, Meteorology Lab. Good evening, all, he says. While we're waiting from David Holcomb, why anyone not on the Tim Vasquez Meteorology Lab Facebook page should search and join it. And I got locked out of Facebook this morning because I was over sitting in the Lowe's parking lot with my phone. I was going to ask a question, and Facebook freaked out and locked my account, and then I had to come back in, and when I got back in, it asked me to either input a phone number or pick from a group of my friends, a list of my friends, who was who. Well, my phone number was from Oklahoma, like 3 years ago. And the friends, you know, I've got 1,200 friends on there, and I don't recognize most of them, so I was really messed up. I had to, like, upload some documents. But they took care of it quickly. Megan John, good evening from Minnesota. Rain moving through. Kevin McKinney says, like the video. I appreciate that. Greg Kerner says, good evening, everybody. And Ryan got marble-sized hail west of Titusville, along Interstate 95. Robert Terrell checking in. Ryan says, radar 430 to 5. Eddie W., evening all. Hope many years on the channel. Thanks. Burl H., good evening. Good to see you got back in your Facebook account. Yep, finally did that. Lloyd McCarter, sunny in North Little Rock, low 80s, very low temperatures, and 63 for a dew point. Eddie W. looking for an MCS moving through eastern Iowa. We'll be looking at that later. Mike Estwick is here. Mike Bexley also. Mike Estwick looking for 90s in Denver, lower 90s. David Holcomb watching this on 144p, and it's still skipping bad. His internet is not very good there. Okay, Ryan says audio is good, and Mike Bexley says happy birthday. Okay, excellent. All right, we'll take a look at the weather here, and I'm sitting here thinking, can I show this webcast? Let me see if I can bring up the first webcast, and I guess you can watch the editor here. Hey, there's that mirror effect. Let's see here. To do that, I'm going to have to, let's see here, special, this is the broadcaster software I use. So what I'm going to have to do is enter a media source, and let's see here, I'm going to have to add one. We'll call that birthday. And I'll browse over to that real quick. Okay, let's see here. Okay, so we're looking, yeah, here it is. We're looking for that very first broadcast. I've got a couple of them. Yeah, okay, 6/27/15. Okay, let's see if that works there. Yeah, here it is.
June 27th, 2015.
I don't know if the audio is
coming there about halfway
because,
between Houston and Dallas. This
yeah,
is the sounding from Fort Worth, Texas for this morning. This is from a radio
that's what we're talking about. The forecast.
Released from the surface, goes
2
up
years
about
ago.
15,
This is the very
20
first
miles, and it gives us
broadcast. Hopefully you all can hear this.
With height. And what we see here is that there's a whole lot of moisture up to about 15,000 feet. Above that,
there it is.
Pretty dry.
You can see us putting
That's a pretty good depth of tropical air, but then again, that's what we expect this time of year. We need to see it about 10 or 15,000 feet. Radar picture is not showing a whole lot, just scattered activity from north of Houston out to Austin. A lot of that activity is shutting down.
Okay, so anyway, there we go. There's a bit of the first broadcast, and hopefully y'all heard the audio on that. We do have some thunderstorms out in Nebraska. You can see those right here in the North Platte area. We can take a look at that on GR level 2. And we've got a severe thunderstorm warning for that area. Pretty much right down Interstate 80. And it kind of looks like a big mess. You can see that we don't have very good reflectivity gradient. So the cores are pretty well right in the center. It's kind of like a big elevated mass here, so probably the main threat from this is going to be wind and maybe a little bit of hail with these higher reflectivities. So you see right here, we're getting about maybe 62 dBZs in there. And there's the severe thunderstorm warning. They're looking for wind gusts being the main hazard. And that system continues to move quickly westward there. The radar site located to the north, or to the northeast, so you can see that we're not in a good position for looking at wind, because the wind, the outflow from these storms, mostly blowing this way. The radar is sampling the velocity perpendicular to the wind, so it's just going to show pretty close to 0 knots when we try to sample those. We would need a radar further out to the east, and you can see the next one is Lincoln. But if you try to sample the winds out from this range, you're going to be overshooting the downdraft winds. You're going to be up at about 12 to 15,000 feet. So this is where you have to rely on spotters to be able to see what's going on. There's a quick look at what reflectivity data we can get, and this is showing outbounds right here and inbounds right there, and this is probably just mostly the inflow feeding into the storm. We just cannot see the outflow, and part of that is due to the range. It's far even from this radar up here. So we're looking at maybe, let's see here, probably about 40 to 50 miles away. So anyway, there we go. There's that storm right there. And let's check out the moisture field. I clicked on something. What is that? Normalized CAPE. Now, theta E can be useful even on strongly dynamic situations like this, and we see that the theta E ridge is pretty much right through here where I have the red line. So the storm right there is pretty much feeding right along that, and it should continue with this pretty good inflow as it moves eastward down the I-80 corridor over the next several hours. Now, one other way we can look at the field ahead of those storms is just look at the plots. So we have our storm right there, and you can see the rich moisture just to the north, like right in this area. You see the dew point 65 to 66 right in this area here. There's 65, there's 69. So pretty good air right out ahead of the storm. Should feed right off that tongue of moisture. And down to the south, you can see the drier air working in from the south. That's kind of maybe a bit of a dry line. Let me see if I can plot that. So this would be, you know, some sort of dry line, maybe oriented something like that. Okay, let's see what's going on elsewhere. There's our enhanced risk out ahead of that area of thunderstorms there in Nebraska. 250 millibar chart, that's kind of the key to the pattern. And we see that we have a large, long wave across the eastern U.S. So this is representing cold air out over this region. And there's a response in the jet stream field. We get that southward dip around that cold air mass. Out to the west, though, big ridge. And we can zoom in on that real quick. There we go. The next upstream trough over Idaho and Nevada. And then we've got another low way offshore. That'll probably enter the picture later. Okay. 250 millibar chart looking like this. Looks like we're picking up maybe, could be a subtropical jet. It's definitely got an anticyclonic curvature there. The main polar front jet well up to the north and out over the east coast. Looks like we got about 110 knot winds. So if you're flying from New York City to Atlanta, it's going to be kind of slow progress as you move through those winds. And so a lot of times the airlines will route the planes above or below the jet stream, so you'll find yourself either at 41,000 feet or way down at maybe 27 to 29,000 to escape the headwinds. And sometimes they will deviate. So if you're going from New York, they'll maybe cut south a little bit and then bring it west like that. Okay, 500 millibar chart. Also showing the 50 knot winds over the East Coast right there. And we see northerly flow out over Texas. And down along the coast, you can see a little bit of a trough down here. So this is helping to generate those sea breeze thunderstorms, helping them to persist. And you can see very little in the way of capping. The 10 Celsius line this time of year, it's pretty tightly associated with the edge of the cap. So basically 10 to 12. That's when you're getting to the stronger cap air. And then we've got the 14s over Denver and Cheyenne. Now, the higher you get in the terrain, the less of an effect there is. And especially when you have orographic development, the storms can easily get going. And that's probably what we saw earlier today. So once they launched off the mountains, they moved eastward, and we've got our MCS underway. And there's our 850 millibar flow. And keep in mind that this is showing the humidity. A lot of these sites, they focus on humidity instead of dew point, and that doesn't help us very much as forecasters. We do see that this morning there's a little bit of a low-level jet, maybe 30-35 knots. And you would have to kind of work out the moisture in your head based on the plots here. But it looks like there were 14 Celsius readings in Midland. Looks like 12 at Oklahoma City. And probably in between here there was some moisture. So we'll look at the models for that. Okay, here's our potential temperature chart. This is a different look at the weather. And you can see very strong northwesterly wind across Saskatchewan and Montana. And you can see the southward dip in the potential temperature lines. So this is a new cold front coming south. And it looks like if you could probably bring it even further south like this. So this is the system that we saw yesterday in the Alberta area when I brought up radar scope and we saw the thunderstorms in Calgary and Edmonton, actually west of Edmonton. That's the front now moving south through the northern plains, and we'll see it moving into the Nebraska and Kansas area over the next couple of days. Okay, and there's our storms on the satellite right there. Very interesting look at them. There's the Nebraska one there with a thunderstorm warning. And we've also got some smoke out over Arizona. You see that right there. Now, I brought up one of the smoke charts from SPC. Actually, this is a fire warning right here. So you can see they've got a critical risk out here. And there's a specialized multispectral satellite product that we can look at. And I don't know if you can see the smoke on here. So they're finding the infrared bands that really bring that smoke out. And you can see they've got kind of a turquoise color right in here, just south of Flagstaff. And there's another one in southern Utah right there. And one good product for seeing that is, of course, the polar orbiters. So there's the Arizona fire, and then there's other fires right here in the mountains of southern Utah. And I remember I took a road trip through this area in 2001. Very beautiful. I forgot the town names. They definitely had a Mormon sound to them. But yeah, there's that one fire right there. Hopefully there's not too much going on with that. As far as Texas, we can see the sea breeze very clearly working north, and there it is right there. And as I mentioned, it's a mesoscale feature, and it's triggered a few thunderstorms out along it and out behind it. It looks like we've had a couple storms manage to get going in the Dallas area too, just north of Fort Worth. And we've also got a hurricane out over the eastern Pacific, and this is, I think, Guadalupe Island. Not Guadalupe. I'm sure one of you know it's that island right off Mexico. We'll take a look at the SPC and or the Hurricane Prediction Center. Let me see if I can figure out where I put that product. I've got about 40 windows open. There we go. Okay, so that hurricane that you saw out there, that's Dora. Okay, so tropical storm, not quite up to hurricane, but very close. I was convinced that it was a hurricane. 55 knots there, 995, so that's come down a bit. And then there's our motion, pretty much going straight to the west-northwest. So let's put it all together in terms of baroclinicity and thickness. For that one, we go to the thickness and pressure. And this is definitely showing that cold air mass pushing southward across the eastern U.S. And also not, it's pushing southward. It's a density current, but it's also being advected by this high pressure in the Ohio Valley. So that's creating a northerly pressure gradient, bringing the air kind of southward out over the northeastern U.S. So probably a very beautiful day. A few showers, a little bit of a cold core system out over Vermont, New Hampshire, and upstate New York, but otherwise, very beautiful weather for this time of year out there. Then down over Texas, you can see that we do have the Gulf open. Not a very strong pressure gradient, but enough to get some pretty good flow going in the Central Plains right there. And you can see that system making its way through the northern Rockies area. So that's the new cold front. And the old occlusion way up here in northern Alberta. And then the warm front, well, just taking a guess, it looks like that somewhere in Nebraska. Maybe where we have this bend here in the pressure isobars. So I'm going to go with something like that, and there's the tail end of the front in California. Well, we can take a look at the air mass out ahead of this system. We can go to North Platte. This is what it looked like this morning, and it does look like they had some moisture. It's like low to mid 70s, low to mid 50s dew points. Very good depth. That really stands out. 150 millibars of depth. So really, to get that to get convection, all we need is a temperature. We can just bring this down. And that's the surface right there. All we need is 83, 84 degrees. Yeah, we've definitely got that. And there's our cape. So all you need is a little bit of heating, and looks like no problems there for North Platte. And you can see a little bit of curvature. Well, yeah, maybe a tiny bit of curvature on the hodograph. So we basically go from southerly at 20 to southwesterly at 20, and then northwesterly at 30. So that'll give a little bit of curvature on the hodograph. And this is where mid-level wind strength becomes important. Because if it's weak out here, then you basically go from southerly winds at 20 to mid-level calm, and then upper level northwest at 30, and that means you've got very little curvature on your hodograph. So just enough to get a little bit of rotation going, but it looks like we are lacking something. Maybe we're getting a little bit of dry air ingested in that storm, and there's definitely a lot of dry air aloft to give us kind of outflowish storms. Okay, we'll take a quick look at the dynamics, and yeah, it looks like we've got a little bit of a shortwave this morning. This is at 18Z out over western Wyoming, approaching our area of interest right here. So by evening, yeah, most of what you see right here, this looks to be affected by convection during the afternoon, but that little wave looks like that's probably worked eastward. So started out right around here, 4 p.m., maybe somewhere in here, and then by right now, maybe right there. So out ahead of it, that's where we have upward motion, and that helps remove any cap and helps destabilize the atmosphere. And here's where we got a little bit of shortwave ridging. So downstream from that, probably a little bit of a warm day in western Iowa up to Minnesota. And then down over Texas, we can see a little bit of that troughing that probably associated with those showers. And let's check that out on the, let me go back to the polar orbiter data. Looks like that's probably one. Actually, I think that this may be the sea breeze, or one of those two probably is. We can probably go to one of the other. Yeah, definitely showing up right there. That's the sea breeze rolling in, and then several hours later, it finally got up here, up to the north part of the map, and gave us those showers. And right now outside, we're looking at. We can take one more look out there before it gets dark. We'll switch it over, and we have pretty much cleared out there. Okay, let me take a look at the chat here and see what we got going on. I'm looking at my stream health, and you can see it's kind of yellow. Actually, I have to switch that over to show you guys. Yeah, this is how I monitor the feed when I'm doing the channel, and you can see stream health is yellow, so it looks like maybe a few problems going. Let me scroll down here. I've got a few tools I can... What I need is a tool for my voice. It's breaking up here. But you can see the analytics here. And let me go over to the stream health. I've never used this. If I had somebody sitting here watching this, they would be able to kind of monitor this and see what's going on. And this tends to go up and down depending on if I'm airing a product with a lot of motion, like satellite data. That'll bring the stream output down. And so I'm kind of looking at this. I'm going to be messing around with the encoder over the next few days, and I'll probably try to get this where the stream looks even better. Okay, so let me fix my window here, and let's see here. Ryan says, the new beginning after Storm Track 2015. Brett Dean says, hello all, 71 in southern Jersey, beautiful. Have to go to work, nightshade. Thunderstorms have been around 24 hours, no severe. Brett Dean believed to be having cold core convection due to storms popping up at 3 a.m. last night. Ray Woody joining us, and Greg Kerner. And Mick from Australia saying good day there. Okay, let's press on. And we do have some weather going on in Europe. Very active weather pattern. You can see we've got this big low out over the British Isles. And the jet stream well to the south over Spain. And up into Italy like that. That's unusually far south for this time of year. There's another jet stream segment over Sweden out to Russia. So you can see we got a ridge over Germany right here, and the main trough. This is a negative tilt trough extending into Spain like that. So out ahead of it, we've got quite a bit of lift over France, over the British Isles, and let's see what it looks like down at the surface. Wow, got some low pressure systems out over France. So where would we put the fronts? Well, you always want to go to the south part of the map. So we're doing kind of an analysis here for Europe. So it looks like there is low pressure out here in the Mediterranean. I can see a cold front right through the Straits of Gibraltar. Okay, so there's a system right there. This looks like an occlusion over Belgium here. Another one over Ireland and England. Yeah, it looks like a bit of a warm front over Germany. So this looks to be kind of like another system here. So there's a warm front. Yeah, we don't often do these analyses out over Europe, but yeah, some very interesting weather, and you can see we've got some heavy precip over France right here, and other showers northward into the Netherlands and the London area. And there's another little occluded system right there over the Bay of Biscay, looks like just west of there. And I need to tell you guys, I've been working with some data for World War II. I don't know how many World War II historian type guys we have here, but let me see if I can show this to you. Yeah, I look at weather for everywhere. I mean, Europe, Africa, all that. I've went through the maps like yesterday, trying to find unusual weather. That's when I was talking about Australia. So I'm starting to try to find a lot more of these extremes for you guys. Like we're going to start looking at the weather internationally a little bit more. Now, as soon as this one finishes loading, yeah, let me bring this up. This is a weather chart from 1942, I believe. Yeah, this is a hemispheric chart. Okay, September 1st, 1942. So this is right during the middle of World War II here. So let me zoom this in. So basically what happened is in 1942, Germany decided to launch Operation Barbarossa, which was the invasion of Russia. And they pushed eastward. Actually, I think that was in 1941 when they did that. They made progress in 1942, and then that fall, they got stranded in, I'm sorry, this is sideways, but here in Russia, they advanced eastward, and they got bogged down by weather. Made things really muddy, where they couldn't move their heavy armor, and they really got messed up, and they made it to Stalingrad, and you've probably heard about that. Very, very harsh winter, and the Germans were defeated in on that front in February of 43, and they got driven back during that year, all the way back to Germany. So I'm going to be putting together something about that, probably as a separate program, and we'll actually look at these synoptic scale weather systems and talk about how that had an effect on the German army there. We'll see the rain coming through and the cold weather, so we'll be looking at that there. So anyway, this is September 1st, 1942, and you can see a weather system coming on shore there, unfortunately sideways, but I didn't have a chance to prepare. And there's the U.S. right there. There's some of the plots at that time. And you can see a few stations up in the Arctic there, but very little weather data to go off of, and there were some really good analysts that were putting a lot of this information together. Okay, I think I've lost my place. Okay, yeah, we're looking at European weather. Okay, let's move back to the U.S. and see what's going to be happening over the next few days. Okay, somewhere in here I had a precipitable water chart I was going to show you guys. And hang on, give me a second. Okay, it's lost in the sea of links. Okay, well, oh, there it is. Okay, precipitable water. Okay, here we go. Let's check out what this looks like, because we're getting into the middle of summer. And this has a big bearing on the forecast, and you can see 2 inches precipitable water starting to come on shore here in Texas. No wonder that we've got thunderstorms popping up and showers. And you can see that, well, looks like it makes a little bit of progress into Louisiana over the next couple of days. There's those 2-inch amounts right there. This is by Thursday, and then by Friday, the main axis of that deeper precipitable water is out over Tennessee. And I noticed that it didn't quite come on shore. Something was stopping that, because we do have kind of like a southerly gradient, but it's not making much of an advance. And I think I may know the reason for that. So let's go to the mesoscale models, and I'll show you why. Let me find where we're at. Let me just close these European windows. Yeah, let's move this down to the south central U.S. Okay, this is the high-resolution rapid refresh model. This is looking at Texas for this evening. We're looking at rain. This is basically a plot of rain and pressure. So it's showing the sea breeze. This is the map for 7 o'clock. It's maybe a little bit slow, but it does kind of represent the sea breeze right there. And then it looks like later on, yeah, see here, develops this big precipitation field. So this is basically a lot of convection just going to town on the moisture and starting to eat it up. So this has an effect on the moisture advection into Texas. So a lot of showers overnight off the coast of Texas right there, and that's having an impact on the moisture coming inland. Okay, so that would be the reason those higher precipitable waters are not making it in. Let's take a look at the dew points. That's another piece of the puzzle here, and we're also going to look at the wind field. Current chart at this time looking like this, and you can see the cold front moving pretty strongly into Wyoming right there. And near the nose of the moisture, that's where a thunderstorm is right there at this minute. The moisture axis all the way from Texas up to Nebraska, and that convection is going to move eastward or southeastward and feed off that moisture axis. And you can see a little bit of a dew point from central Kansas down to central Texas like that. So when we do the webcast tomorrow night, things are going to be looking like this here. This is Wednesday. So it looks like we have our front moving through western Iowa, in through Nebraska, stalling out just a little bit. Stalling out for some reason, and that's probably due to some upper level ridging. The moisture axis, though, is intersecting the front over Iowa, so probably some good chances for precip in that area right there. Going into Thursday, let's check out what happens. Okay, now you can see things are coming together in the northern plains. So now we've got a push of cold air, and this is probably due to an upper-level shortwave trough moving through this area and kicking things southward. So there you go. Behind the trough, we've got some shortwave ridging. In between there, we have the anticyclone. So we expect that to be well off this way. And that strong anticyclone back there is actually what's pushing a lot of this cold air southward. So it's actually the high pressure area. And the leading edge, let me go back here. Let's see, Thursday. Yeah, there's the leading edge of the cold front. And then the warm front, that's kind of hard to place, but I'm going to go with maybe something like that. And that would make this an occlusion here. And you can see the moisture axis just generally from Kansas City up to St. Louis. So good chances for rain right here. Missouri up to Iowa. There's probably going to be an MCS there on Thursday. Then the system comes even further south on Friday, coming down through Oklahoma into West Texas. And looks like the stronger, we're looking at the coast right here, the stronger gradient and the better moisture seems to be intersecting in East Texas and Southeast Oklahoma. So probably a chance of an MCS along the Red River on Friday. And that would continue overnight because MCSs love in the nighttime hours. Okay, Saturday. Getting up to July 2nd, it looks like our front retreats northward as a warm front. There it is right there. So precip chances for Oklahoma and Kansas. And then the rest of the system is sweeping eastward through the Great Lakes into Ohio and Tennessee there, or Ohio and Pennsylvania. Then for Sunday, cyclogenesis in the Great Plains. You can see the moisture starts trucking back to Texas and Nebraska. So good upslope day for Nebraska right there. That's where you're going to want to be if you're a chaser. And you can see that the dew point in this area right here in Kansas, very packed together. So there's probably something going on here. Maybe an active dry line. So we might look for storms in this area of Kansas also on Sunday. Then we get up to Monday. Looks like our front kind of stalls out right here, Illinois to northern Missouri. So probably good chances for rain in the Corn Belt, and I'm sure the farmers are loving that. I don't know, is that going to disrupt the harvest? I know the corn up in Nebraska this time of year is usually getting up to about 5 or 6 feet. The rain is definitely beneficial, but I don't know if that interferes with the harvest or when that is. Okay, July 4th. Still looks like a stalled front, maybe indicative of MCSs, maybe one after the other, moving through Iowa. So probably another one through Kansas City, Omaha. And as far as Texas, I really don't know. That's going to depend on the upper level patterns. Way down here, away from the dynamics, you're looking at you have to look at the ridging aloft, 200 millibars. So we'll look at that in a little bit. Then the rest of the chart, just front hanging around in the northern plains. Looks like we're under southerly flow most of the week. Yep, pretty much all week. Southerly flow and action in the central and northern plains. Okay, let's see here. We're going to check out the upper level ridging. We'll check that out real quick. That's the last piece of the puzzle. Okay, so we've got a polar front jet right there coming through the Rockies on Thursday. It's kind of unusually far south, but that's going to support any MCSs that we have in the Nebraska and Kansas area. So that's right out ahead of that. Approaching jet max, probably going to see severe weather with this 70-knot flow aloft. The storms are going to be very well ventilated. So I would be looking at severe there for Kansas on Thursday and Friday. Then the main trough pushes out over the Central Plains, and that means cooler weather coming in. There's a pretty good jet max right there through Chicago. And then getting into next week, we're bringing in the southerly flow across Texas. So what I'm looking here for is ridging over Texas, and I'm not really seeing that. We're remaining under westerly flow and even a trough approaching. So what I'm looking for here is a big ridge building in. If that would indicate a very strong warm-up and a return to deep summer conditions. And I'm not seeing that. In fact, I'm seeing this little wandering upper-level mesoscale convective vortex over northeastern Oklahoma. So it looks to be kind of mild next week. Across Texas, southerly flow, and I think we're going to see an active sea breeze. Scattered showers coming inland every day next week, the July 4th weekend, and chances for a precip, we'd probably do like 20-30% across much of the eastern half of Texas. Yeah, see that? Little convective vortex that's probably associated with maybe a little cold pool aloft, and that's going to definitely keep the chances of rain going for next week. But over the Rockies, yeah, they're getting a ridge. You see this here? I'm going to draw this high pressure or high heights right here. So there's the anticyclonic flow right there. That's going to mean hot and dry weather for Utah, Colorado, and Wyoming, and fire danger because of the fact that we've got high fire risk right now. So that's going to probably mean that's going to persist. And it looks like some sort of troughing through the Gulf Coast right here. So that just spells rain for Texas and hot weather for Colorado and Utah next week. And we can pretty much bet on that, because now we're looking at synoptic scale pictures, not so much the mesoscale, and the models are pretty good at handling this out to about 250 hours. They're good at handling the large scale picture. So I may not know too much about this exact upper level low pattern, but I know that this area here is probably below normal as far as heights, and here it's above normal. So that's kind of what I'm going off of for next week. Definite ridging out over the northern plains next week. Okay, let me take a look at chat here and see what we got going on. Brett Dean, good night. Leaving for work. Be weather savvy. Dowanigan, strong thunderstorm in Maine presently. Yeah, why not? We can take a look at Maine. We'll just load that right up. I don't know what part of Maine, but let's see, what do we got up there? I don't think we've ever looked at Maine. We'll go to Portland and check out their radar. And we got that loading. And that's going to be, remember earlier we talked about a cold core low. So this is not like a warm weather scenario with air mass thunderstorms. This is a cold core pattern. And there you go right there. You can see the showers across Maine, and it looks like there's a slow northeastward drift on these. So there's Portland right there, and definitely very low reflectivities there. And for example, on this stuff here, we can see the tops on this are in the 14,000, 15,000 foot range. In fact, we pick up the bright band right here. You see that there? Actually, no, there it is right there. And that's due to the melting level being at that level. You get water-coated ice particles here, and they reflect very well. And all around the radar at that range, they're all at the same elevation. Maybe I can bring that up on the cross-section. I'm going to go from the radar out to the southeast like that, and we'll see if we can look at that melting level. Yeah, so right there. So basically the melting or freezing level at about 8,000 feet. In fact, that yellow line looks to be it. I think maybe it's pulling that from the radar data somehow. So you can see how consistent that bright band is as we sweep through all this part of the radar picture here. Okay. Some sort of marine warning off the Massachusetts coast. Strong thunderstorms located from Essex to Patience Island. Maybe I'll go south a little bit. We'll look at the Boston radar. See what's going on there. I've never been to Massachusetts. No, I've never been there. I've been to Vermont. I've been to Maine. I stopped at Bangor when I was going to, back when I was in the Air Force. I've been to Connecticut, and I have not been to Rhode Island. Okay, a couple more states I got to make. I've been to like maybe 45 of the states, but not Massachusetts or New Hampshire or Rhode Island. But yeah, there's that strong thunderstorm moving offshore. Some pretty high DBZs. We'll take a look at a cross-section of that. Just because it's unusual, we usually don't look at this kind of weather. And there's our thunderstorm, very shallow-topped, 20,000, 22,000 at best. So airplanes can pretty much fly right over this with no problem. But down at the surface, higher reflectivities down there. And you can see that we've got a little bit of overhang in this area. This is the only area we would be concerned about as far as severe weather. So if you're out just ahead of the storm here, you would see this overhang here, and that would be indicative of very strong updrafts. Shallow updrafts, but very strong, and that would indicate a severe thunderstorm right in that area. So right out ahead of the line right there probably looks very scary, and maybe a bit of an Arcus cloud, maybe a wall cloud going. We'll take a look at the velocities in that. Overwhelmingly outbound, so we can just correct that real quick. Put in some storm motion, 220 at 22. Okay, so there we go. Maybe a little bit of light rotation, maybe here. Yeah, that looks to be correct. Yeah, that would be a very weak mesocyclone. So we're talking about maybe 10, 15 knots of shear, just very weak, very gradual rotation in that area. And you can see that little notch right in here. So maybe a little bit of a, yeah, kind of a, I wouldn't want to call it a supercell, but definitely looks like some sort of very strong thunderstorm off the coast there. So that's going to be about 40 miles northeast of Boston. Okay, so I hope that helps you there, Dow Enagan. And Fun with Tech says, good night, Brett. Mick, very hot in Europe this time. So yeah, that would be underneath that ridge that they have. In fact, I've got a map ready. We can take a look at that real quick. Again, well, this is going to be 3 a.m. data or midnight data. But it looks like we've got maybe a front. Let's see here. It's hard to pick out where that front is, but yeah, you can see very warm temperatures there at Frankfurt, 70 degrees at this hour, and lots of 60s out in France and across the Central Europe region. But very cool across the British Isles there and Western Europe here. Okay, Brett Dean says thank you. Mike Estwick, hey Tim, go to frontrangeweather.wordpress.com. There's something you should see there. Okay, I'll check that out after the... we'll check... let me see here. Front Range Weather. Okay. I'll take a quick look at that real quick. Okay, hopefully this isn't eating up my bandwidth, but oh, okay, yeah, there we go. Yeah, I appreciate that. Mike Estwick says, congrats, Tim, well done. Or congrats, well done, Tim. Appreciate that. So, frontrangeweather.wordpress.com. Very good, thank you. Greenville weather, 74 in the South Carolina upstate. That's definitely good. 3 Pistol 7, there's always something interesting somewhere. Fun with Tech says, good job, Mike. And Andrew Hotchkiss, Convergence Line, lots of precip, muddy ground. Fascinating how meteorologists could pull this off. Talking about the 1942 chart there without computer models. Mike Estwick says, hey, fun, you peaked. Kevin McKinney, every cool week is 1 week closer to fall. I agree. I was just thinking last night how it's getting to be just about midsummer. And I really prefer the winter weather. So I really can't wait here for October. Mike Estwick says if anybody likes jazz, they've got an awesome festival in Providence downtown during the summer. Mike Bexley says, enjoy your Forecast Center article. He enjoys the Forecast Center articles in Weatherwise. Thanks. Yeah, I've got a column in Weatherwise. Maybe I should show this to you too, since we got a little bit of time here. I'll have to go to, let's see, how do I have these stored? Yeah, I'll use Thumbs Plus to get to these. I'm going to show you my column real quick here. I don't know how many of you still subscribe to Weatherwise. That's a weather magazine, and I've got a column in there that runs every 2 months. And in that, I talk about weather analysis and forecasting. And it's presented as a puzzle format where you get a map like this, and you have to analyze it. And I'm navigating over there to there right now. Yeah, these are the files here. Okay, so for example, you'll get a map like this that runs in the magazine. And this is all done with digital atmosphere, and you analyze it. You find the isobars and fronts. And then after you're finished, you head over to a different page inside the magazine and you get the completed analysis. And this is all done by me by hand in Adobe Illustrator. And you can kind of compare that. And there's a very long discussion about the maps that talks about all the different features and how it's all connected. So that's another source of analysis. It's another way you can keep up to date on your skills there. Lloyd McCarter sitting and watching, listening, quietly absorbing, looking forward to weather history too. Yeah, yeah, that's going to be very cool to look at the Stalingrad, Operation Barbarossa stuff. If you check out articles about that, weather was a huge factor, and the weather was so brutal during that campaign that you know, there's there's a little bit of, I guess, exaggeration here or there. One source said the temperatures were down to minus 42 there in southwestern Russia. Another source said minus 20. But in any case, it was definitely some very severe Arctic air, and that kind of ground everything to a halt. It allowed the Russians to move, but the troops were really badly supplied. Their uniforms were in very bad shape. There were thousands and thousands and thousands of frostbite cases. On the other hand, the Russians were more used to fighting in that weather, and they were better equipped. So they had the lead, and they pushed the Germans back in 1943 there. Okay, so yeah, we'll check that out. And Mike Bexley says, great learning experience. Burl H says, weathergraphics.com/edu/forecast center. Yeah, there's that too. Haven't updated that in a while, though. Andrew says, anything below 0 is bad. Okay. I think that's about all I got for tonight. We've ran over an hour, so we'll just kind of wrap things up there. Anyway, I appreciate you all joining. And one last look at that storm out over the Atlantic. And thanks for watching, and we'll see you tomorrow.